Alright, you guys, we need our springboard books today and calculators. Right? Somebody will bring it to you, right?
I know, I'm like, so what? So what?
I have yours.
Why are you doing that?
I was on a job before. I was like,
Thank you, Robin.
Alright, I want you guys to open up to page 87. And I want you to try, just put the answers to these three problems somewhere in your book. It's going to help us out later today when we get to a proof. Okay, so put whatever you think the answer to those are. I have to take 10 minutes. Maddie and Holly are here today. They're just taking the ACT, right?
Yeah. What page are you watching? I don't know.
Page 87.
87.
Yeah. All right, pass back paper so you can see how you did on your last work. You got 100. I forgot to write it on there.
I just wanted
You got 100.
to myself.
What do you think on that?
is that how?
Just 4? Oh, okay. That one's good.
I remember when everyone was studying
I'll go
the
down.
Sit there next to Paul.
and so I added one, I was like, what should I waste it?
You like
And
one?
I put back.
Oh, no. All right, Devin, what do you think number 1 is?
X cubed.
X cubed. Very good. Kayla, how about number 2? X to the 4th. And Blake, how about the last one?
That's the ninth.
X to the 9th. Question?
Well, why would you add it if there's like the multiplication there?
I was gonna ask.
When you multiply the exponents, you have to add what's up here. So there's technically like a 1 up here on all of these. So then you have 3 plus 1 is 4, 1 plus 2 is 3, 8 plus 1 is 9. All of those. Okay, so I guess the pattern is when I multiply by just x, just a plain old x, I basically just add 1 to the exponent. That's going to help us at the end of class. Hopefully we make it to there, where we'll use that. I need you guys to get your calculators out. I want to show you something. We skipped over it yesterday, but I think we have time that we can do it today. It's actually going to be number 5 in your book on page 87. But we're going to do it with technology. Assuming I can get it to load. We're going to wind up putting, have we done any graphing points in this class? I can't remember. Have we put them in the calculator and let it plot?
Yeah.
I think we did, right?
Yeah.
Okay, so we're going to do that again with these three lists, but I'll go through how to get to these, and I actually need to change this. So this was actually 16, 8, 4, 2, 1. All right, so if you hit on your calculators, remember if we go to Stat, Edit, it brings us to this place where we can enter lists of numbers. Okay, we're going to wind up graphing those lists. I've labeled L1, L2, and L3 on the board. So that's what we want to enter in to these three places. You should be in the exact right spot. So you just type in each number and then hit enter. You just hit enter right away if you hit Stat. All right, so hit Stat. Edit. So just hit enter.
Graph.
16, 8, 4, 2, 1. All right. Does anybody need help getting those in? Are we all good on that? Somewhere you're still clicking away. You got it? Okay. Just making sure. Might look scared. Blake, you good?
Yeah.
All right. So once you're finished with this, I'll wait till you guys quit typing. You need to quit out of this menu. So you're going to hit second mode, which actually makes you quit. Actually, it should be back at that blank home screen, all right, where you originally started. Then we need to hit second y equals, which takes us to stat plot. Second y equals. Okay, all of your plots right now should say that they are off. So we're going to have to go in and turn some of them on. All right, so hit enter on number 1 here. Make sure you turn it on. So you have to hit enter on. And then.
This is what I was talking to you about yesterday. This is what I meant.
Oh, that's what you needed yesterday?
Yeah.
I'm sorry.
Oh, boy.
Okay, so leave that how it is. Are you good, Harmony?
And now I can't enter.
You don't know. Just need a calculator. I don't know what that is. Summer, will you be able to catch her up if you need help? Okay, so once you turn this one on, quit out of it. Okay, so quit. Then go back to stat plot. And we have to go down to the second one. Okay, so go down to number 2. We're going to select it. Hit enter. We're going to turn it on. Then we need to change the Y list. Okay, so since I made a list of numbers that was L1, L2, L3, I need this next Y list to be L3, okay, this column over here. So if you hit second, and then I forget which number it is. Second 3, okay, see how there's a blue L3 above that?
Yeah, that's an I have an L1.
If you hit second and then 3.
Yeah. Okay, now.
Yeah, you're good, it's L3.
You said it's supposed to be a blue L2.
No, I meant it's in blue on the calculator. Add L3 as well. Okay, so does everybody's screen look like this on plot 2? Yes? Okay, how about more than just Kayla? Everybody?
Yes.
Yeah. All right. I do care about Kayla, but I care about all of you. So we're good with that. The last thing we need to change is the window. All right. Do we have any negative numbers up there? That's an easy question. Huh? Oh, sorry. I mean on the board, not on the screen. On the numbers we inputted. Okay. So we can start at 0. We don't have to worry about any negatives. Yeah, Blake. Oh, just hit window.
Go through four.
Okay.
Before it took me to a whole different place.
Okay. This is our X list. So what number do you want to go to for our X list? 5? How about maybe 6, just so this point isn't at the very end of the graph? Okay, I get what you're saying. There's no reason to go bigger than 5, but let's just make it so everything fits on for sure. So let's make our X maximum 6. All right, so if I go down, oh my gosh, where'd my calculator go? Hello? Oh no. Okay, it's back. All right, so I make that 6. And it's fine, we can go up by 1s, that'll work. Now down to the y's. 0 again, we don't have any negatives. And what's the biggest y value out of these second 2 columns? So what do you want to make the maximum just so it all fits? Just like 20? Okay, 20 works. Max 0 to 20. And now we're finally set. You can finally put these on your graph. So you have something like that. Sorry. Okay, so we see 2 different types of graphs there. Okay, on my screen it's colored, so maybe it's a little bit easier to talk about my screen. What type of function are the blue points up there? What type of function is that?
The constant.
Constant, okay. So it has a constant what, Blake?
Constant, like, constant difference.
Constant difference. I like, when we're using graphs, I like a better word than difference. What is that? Like it goes up so many and over so many. Slope. Yes, okay, constant slope. All right, so what type of graph is that? Like, is it quadratic? Is it exponential? Is it linear? Is it not linear? Why not linear?
It is not linear.
Why is it not linear?
Thinking it's linear.
And now you're thinking it's linear.
Yeah,
Why?
because it's a straight, like, well, it's not straight, but it's like, I don't know how to explain it, but it's like, it's not curved, it's straight.
Not curved. So all the points are in a line,
Yeah,
right? So linear with that keyword line in it.
yeah.
Okay? Yeah, you're right. Okay, so the blue dots are linear. Okay, this is constant slope. Okay, Blake gave us constant, Harmony gave us slope, Mia gives us linear. Okay, so yeah, that's exactly what it is. And your book asked you to talk about that a little bit, so you can write whatever you want on 5C. Okay, you can talk about that a little bit. We did A and B in the calculator, so the only place you really need to answer is 5C. All right, so whatever's going to help you remember it and why, you can go ahead and put that down.
The same thing I just told you.
How'd you write that?
The angle is just straight line. No, I just told you. Why do you have to see something I just told you? You don't believe me?
I just want to see how you wrote it out. No. What did you put? Constant. Alright, can I help you remember? I like it. All right, you guys put your calculators to the side for now. All right, I think we're done on that. What?
Are we done with calculators?
Done for now. Will you move just a little closer to Kayla so you guys can work together? Blake, do the same. Move up this way.
Okay.
I want you to try. I keep looking at my geometry book. It's not going to help. I want you to try working in groups. So like you're a pair, you're a pair, you're a pair. This will just be a group of 3 since we have leftovers. I want you to try working on number 6 on page 88. Work together on that. Yes. Number 6. You just sat. through this. We'll just go around. People just answer as we go around. So Summer, you're first. So it's a sub 1. A sub 1 is 4. Harmony, what's R? Yeah. You don't necessarily have to write times. You can just write 2 because it's implied that we're going to multiply. But it's fine. It's not like I would mark it wrong. A sub 2, Sammy. Fill in that blank for me. Okay, so 4 times 2 to the first power is 8. Remember, if we're doing order of operations, we have to do 2 to the first and then multiply by 4. So 2 to the first is 2 times 4 is 8. Okay, A cubed. Devin, what do I need? Oh yeah, 2. Alright, so 4 times 2 squared, 16. What do you need? Okay. You know that. You're going to get caught on camera though. Alright, A to the 4th, Sam. A 3 goes in the blank, right? So 4 times 2 cubed is 32. Paige, give me the next one. 4. Is there some sort of pattern going on? Is this getting too easy?
Yeah.
Okay. Mia. Just because you spoke out of turn. Okay, 5. It was 128. Oh, I forgot there's 2 blanks. I'm going to do the work for you. All right, Kayla, give me the last one. 4 times 2 to the 9th equals what?
2000.
Okay. So Blake, I'm going to put you on the spot. What's the pattern? What sort of pattern do we have?
Multiplies it by 2 every time.
Multiplies it by 2 every time, sure, but is there a way that like some of our numbers up here relate, especially the ones that we're filling in blanks?
They go up by 1.
They go up by 1. What about, is there anything else we can compare them to?
A sub number. It's just take 1 away from
You don't know. Okay, Sammy, say it louder so Blake can hear it this time.
the A sub number. You just take 1 away from that.
Okay, so she's saying this number, just take 1 away from it, and you get the exponent. Okay? So if this subnumber is 2, the exponent's 1. If the subnumber is 5, the exponent's 4. If it's 10, it's 9. Okay, so just take 1 away from it. That's exactly what you want to do. Okay, this leads us right into number 7. Use A sub 1, R, and N to write a formula for the nth term of any geometric sequence. Try that on your own. See what you come up with.
Have we wrote it down before?
I don't think so. Might be on your yellow sheet though. But think about it first. Don't just copy it right off your yellow sheet. Bunch of cheaters.
Hey, you gave it to us.
That's true. I said you could use it whenever, so. This is geometric, yeah? That's for you to decide. Yes. Does everybody still have their yellow paper?
Yes.
I have extra ones if you lose it. Nothing. I think I got it right. The double equals? Just in case you didn't feel like looking back to the left. There it
did
is.
it right, Miss Noll.
You think so? Alright, you guys found it on your sheet, so what is it?
A sub n equals a sub 1 parentheses r n minus 1. Parentheses.
I'm bailing on parentheses. I don't know, just felt like it. Okay, so let's relate this formula, see where it came from.
Where is that
Okay.
on the paper?
Isn't this a sub 1 in the example we just did?
Yes.
Didn't we point that out in the beginning, right? And didn't we point out what R is in the beginning? So like this is our R, this is our R, this 2 is our R in every case. Okay, and then we just talked about it's this sub number, or n, minus 1. Okay, so that's exactly where that formula comes from. We just did an example that uses it. So now we have it. Now this works for any geometric sequence, not just our specific one with the squares from yesterday. All right, try number 8, and then I'll have 2 of you put the answers on the board. Okay, I'll give you a hint. On part B, you're going to need a fraction. And to put a fraction in your calculator, you have to hit, I forget what it is now, alpha, y equals, enter. Okay, so you should use some sort of fraction on number 4, and I can tell you what it is, but I'm just going to tell you how to put it in your calculator. Why did I say number 4? Part B.
Small.
So what is that in the fraction? Oh, that's actually right. That works. Shouldn't be 4 and 5. What do you got? No. It's 2. I'll put 2 every time. Right. Yes, I want to show you. said. She's the worst.
She is.
Yeah, 1 to the 9th pound, or to the 8th pound, so. So you should. You should have learned them. What do you guys do? The first one? You guys are done? So let's take some one. In this case, we have just 1, so we need to start with 1. Hold on, stay with me. So we're at A sub 16, that's what it's asking you to find. One, because that's what A sub 1 is. Times. And then you were just describing the common ratio. So you what's the common ratio? We multiply every time. Just hold it. Activity times 2. Okay, and this is our coordinate, that's it, n minus 1. So what's n in this case? 16, that's a 16th power. You type that in your calculator. It's in it. Okay, all this looks good. I'm going to do one picky thing. I'm just going to move that inside. It does. To me, it does. Okay, but these are right. You should have gotten 32,768 or
116.
0.0625, which is 1/16.
Should I wrote A1?
Oh, you're fine.
Oh,
Alright.
but did you get the right answer? I don't know how it was like.
Oh, yeah, you got this, you're good, or 1/16. Okay, a lot of you had trouble, you thought the common ratio was 4, but we're not multiplying by 4 every time as we go along.
Multiply by, yeah, by 0.25.
Right, so we're dividing by 4, or multiplying by 0.25, or multiplying by 1/4. It's all the same thing. Okay? But whenever we talk about geometric sequences or series, we're always going to talk about multiplication. Okay, so we're going to talk about multiplying by a fraction. All right, we are going to make our way through this fun-looking thing on page 89. Okay? But I'm going to help you through it instead of making you read it and try to understand it. I'm going to attempt to help you. I hope it works. Alright, so you'll probably just, I don't think you guys will have to write much because we're going to do exactly what it says in your book, but you do need to follow along because this is one of your state standards. You're supposed to be able to do exactly what we're about to do. Okay? So, talks about at the top, the sum of the terms of a geometric sequence is a geometric series. Okay, so remember series is when we start adding all the terms together that we find. We did that with arithmetic in the last section. So now we're just going to do it with geometric. So we're going to add all the terms together. All right, and this is going to be a finite series. Okay, so think about what infinite means, and what do you think finite might mean? Not infinite. Okay, so without using that word, what would it mean? Short? It ends, right? It has an ending, right? Infinite would go on forever. Finite is going to have some sort of ending.
Finite equals final.
Sure, we can go with that. I like it. Finite has a final. Is a final? Has a final. I don't think there's any funnels. All right. To prove this, all right, it tells you in your book to derive the formula. Step 1 requires multiplying the equation by -r. Okay.
Finite was finished.
So we're going to take this thing and multiply it by -r. Okay. So if I take -r times s sub n, what am I going to wind up with? Anybody can raise their hand and tell me if they have any idea. Blake, what do you think?
Negative RS and negative.
Hold on, just the first part, just the left side. So what'd you say?
Negative RSN.
Okay, so instead of saying SN, say it the right way.
Negative RS.
Not of, though. What is it when they're down low? Harmony, say it louder so you can hear. Okay, so it'll be negative RS sub n. So negative R and S don't have any like terms. So the best we can do is just kind of write them together, smush them together. So this will become negative R S sub n equals. Okay, so what happens when I multiply negative R times A sub 1? I get negative A sub 1 R. Okay, now coming up is why we did this in the very beginning, so we can make sense of what happens here. What happens if I multiply A sub 1 times R times negative R? All right, so you're just looking at the book, but does it make sense? It really does. Okay, I get negative A sub 1 R squared. Okay, and it's just the same thing as this first example. When I did x times x squared, I just added my exponents together. So when I do A sub 1 R, okay, I'll write it down here. So A sub 1 R times negative R. Aren't these both 1s up here, technically?
Yeah.
So I add them together, and that's where this squared comes from. Okay, so that becomes negative A sub 1 R squared. That's why they write it that way in your book. So what happens here without looking at your book? What do we get?
Negative A sub 1 R cubed.
Summary, you agree? Okay, so I already have R squared, so I'll write it out down here. So A sub 1 R squared times negative R. But do you agree again that this is a 1? Right. So negative A sub 1 R cubed, or to the third, whatever you like.
And then negative A sub R.
But it's negative, right? We're going to change the 1 to negative. So negative A sub 1 R to the fourth, okay, minus blah, 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 minus, okay. So how about that last one? There's the one that might be a real stretch.
It's just N.
Okay, does anybody know why it's just N? Blake, what do you think?
Because when you multiply it to the negatives, it goes to the positive.
I don't think that's the reason. Oh, that's wrong.
I'm confused though because it's also, there's also negative A sub 1 R.
They put that on there too?
Yeah.
No, we're gonna.
They wrote it really weird.
Okay, so what would happen on this if I took this part, A sub 1 R sub n minus 1, times, I wrote that too close together, times negative R. Okay. Mia, there's a 1 up here, right? Okay. And we've said that I'm going to add those exponents together, aren't we? So n minus 1 plus 1, well, what is that really?
0.
Well, the 1's cancel out, so what am I left with? So, if we follow what we've been doing the whole time, A sub 1 R to the n minus 1 plus 1. What is minus 1 plus 1? What happens to that?
0.
It's just 0, right? So why write it? Okay? How about just that? And it's negative. Just grab it in. Yeah. You pretend. You squint. Kind of turn your head.
It's like an upside down.
Do you close one eye and cover the other?
And your eyes are closed.
I know, you just have to imagine. All right, so we wind up with this. Okay? And now that we've multiplied the equation by negative r, we're going to add them together. Okay? So we're going to add these together. I'm going to put a plus up here. All right, I'm going to erase all our work because we're going to need room. So S sub n, let's just do the left side first. S sub n plus negative r S sub n. Are those like terms?
Yes.
Are you sure?
No.
Are you not sure?
S
S sub n is, but,
down negative.
well, it's negative and it has what else on it? It has an r, so if we have two different things multiplied together, it's not really a like term, is it? Okay, so we can't do anything other than write it just as S sub n minus r times S sub n. Okay, you just have to kind of write it. We're doing the proof on page, whatever it is. Page 89. Summer, are you awake over there? I guess I missed it. I guess I need to watch you more often. Okay, over here is where it's going to get kind of cool. I think you guys are going to like this. It involves less writing. Okay? What happens to, where should we start at? If I have positive a sub 1 times r plus negative a sub 1 times r, what happens to those things?
Cancel out.
They cancel out, right? So these are gone. If I have positive a sub 1 r squared plus negative a sub 1 r squared, Harmony, what happens there? They cancel out, man. Summer, this one's for you. A sub 1 r cubed plus negative a sub 1 r cubed. What's going to happen there? Okay, so if I have a sub 1 r cubed plus, we're adding everything together, plus negative a sub 1 r cubed, what do I get? What happens? Would it turn into a negative? I don't think so. Let me give you a different example. What if I did 2 plus negative 2? What is that? What happens when I do 2 plus negative 2? I get 0. Okay, so what do you think might happen when I do 4 plus negative 4? 0. Okay. What do you think might happen if what if I do x plus negative x? Huh? All the same thing. 2 plus negative 2 is that?
0.
0, right? Okay, so what if I do a sub 1 r cubed plus negative a sub 1 r cubed?
0.
0. Just 0. Just stop there.
Does
Just
everything just cancel out?
this cancels. All right, those are gone.
Does everything else cancel out?
It's pretty cool though.
No, it's messed up.
Okay, well I'm gonna say it's cool.
I'm gonna say it's messed up.
Right. Inside these dots,
Does everything else cancel out?
a lot of it does. Okay, not all of it though. Okay, inside these dots, do you agree that to get to the very last term, somewhere there's a positive a sub 1 r to the 4th?
Yeah.
Isn't that like the next term that I would have written if I was going to write them all out?
Yes.
Okay, so this is gone, isn't it? Okay, and do you agree if a sub 1 r to the nth is my very last term down here, wouldn't there be an a sub 1 r to the n minus 1 down here?
Yeah.
Like the term right before this one, like just take 1 away from this exponent, and it would be the one right before it.
Yeah.
So that would mean it would cancel this, wouldn't it? Okay, so that's gone. So all I'm left with is this a sub 1 plus negative a sub 1 r to the n. So I'm just going to put minus a sub 1 r to the n. Okay, we're almost there. We're going to do a little bit of factoring and then we're done. Okay, what's the greatest common factor here? S sub n, so bring that in front. You guys are good at this. So S sub n and 1 minus r equals a sub 1 minus a sub 1 r to the nth. And if I want to get S sub n by itself, okay, it's multiplied by this. Devin, what do you think? Look up here. Take a peek. If I have S sub n times this stuff in parentheses, and I only want this to be over here, how do I move this part to the other side? If it's multiplied by S sub n, how do I move it?
Get.
Nope. Out. Hold on. Hold on.
Out.
Get.
Give me a sec.
Close the door.
Is how do I undo multiplication? I guess is what I'm asking. Divide. So I'm going to divide by 1 minus r. Those are going to cancel over here. I'm going to write it over here. Okay, S sub n equals a sub 1 minus a sub 1 r to the nth over 1 minus r. Okay, this is on your yellow sheet.
No.
Okay, that right there is on your paper. That's the sum of a finite geometric series, and you guys just proved it. Okay, not sure how the schedule is going to be tomorrow because you guys have COSA testing. Okay, well, however it works, I will get you an assignment to work on since I'm probably not going to see you guys in class, all right?
We are not done.
But you guys are dismissed, all right? Calculators away, books away.